Good day once again, students. Today we are going to talk about combining resistors. Combining resistors. We want to combine resistors both in series and in parallel and a mixed combination. So we want to combine resistors. Combining resistors. Resistors can be combined in series and resistors can be combined in parallel. Let's look at series combination first of resistors. If I have my resistors resistor 1, resistor 2, and my resistor 3, my resistor 1, my resistor 2, and my resistor 3. My resistor 1, 2, and resistor 3. My three resistors, I have them like this connected in series. Now, I want to know the total resistance I can use, the total equivalent resistance. The resistance of this is R1, the resistance of this is R2, and the resistance of this is R3. So, what do I do? How do I get a formula for the total combination? First, I will have to assume that current goes like this, current I goes like that. I enters here because it's in series. You remember current in series is equal. Current entry this and current entry this and current entry this, same current I, because they are connected in series. Remember, when a circuit component is in series, the same current pass through them. The circuit components in series, same current. We have three resistors in series, same currents will pass through them. What about our voltage? What about our voltage? Let's assume the total voltage passing through them. The total voltage passing through 1, 2, 1, 3 is measured by this voltmeter as a big V. Big V, or V total. That means we also remember the total voltage here, and here is V total. You remember, because they are connected in series, I told you current is the same, but voltage split up. This voltage will split up. It becomes voltage 1, voltage 2, and voltage 3. Voltage V1, voltage V2, voltage V3. Each of them have their own voltage, voltage 1, voltage 2, and voltage 3. So, if the total voltage is V total, the total voltage in this is V1, voltage in this is V2, voltage in this is V3. And current is the same thing throughout the three of them. Remember that V equals to I multiplied by R. This is our Ohm's law. That means the current in one, the voltage, since voltage total equals to voltage 1 plus voltage 2 plus voltage 3. So the current here is the current, the same current, the total current passing through, the total current, the total voltage now will be I R total, which we don't know, which we are looking for. IR total is this voltage, which we are looking for, which is this, equals to I R1, which is the current here. This multiplied by this is the current here, plus I R2, which is this, I multiplied by this, the current passing multiplied by this because of this voltage, plus I R3. The same thing, the current, the voltage here is V3, which is current here multiplied by, voltage 1, current here multiplied by this resistor because of voltage 1, current here multiplied by this resistor 2 is voltage 2, current here multiplied by this resistor 3 is voltage 3. So V1 is this, V2 is this, and V3 is this. Remember, V equals to IR. Since current is constant, current flowing through air equals to current flowing through air equals to current flowing through air. So this voltage 1 is the current multiplied by its own resistance. Voltage 2 is the current multiplied by its own resistance. Voltage 3 is the current multiplied by its own resistance. When you look at it, current will cancel out. It is common to them all. Current is everywhere. We cancel it out. Then what do we see? We now see that R total, or equivalent resistance, or total resistance, equals to R1 plus R2 plus R3. Total resistance is R1 plus R2 plus R3. R1 plus R2 plus R3. Again, the current going through is the same. And the total voltage is voltage 1, voltage 2 plus voltage 3, which is equal to the total voltage. The voltage here, V1, is current multiplied by R1. Voltage V2 is the current, which is the same current multiplied by R2. Voltage V3 is the current multiplied by R3. So, since V total is V1 plus V2 plus V3, because they are in series, so the total voltage will be total voltage of this plus voltage of this, all combined together, because we say in series, voltage split up. So, but in series, current is the same. So, we write that, then for V total, I times R total, we write it like that. V1, I times R1, V2, I times R2, and I multiply by R3. So I cancels I, and at the end of the day, I have R total to be so for circuit with series combination, all the resistors will be added together. Even if they are 1 million, you add them one by one together. So you add them together, you add everything together. That is your series combination. If you are looking for equivalent resistance of resistors connected in series, the total resistance will be resistance of resistance 1 plus resistance of resistance 2 plus resistance of resistance 3, and so on and so forth. Just simply adding together. Simply adding together. Let us now look at them in series, in parallel. In parallel combination, let's see. resistor R1, resistor R2, and resistor R3. So resistor R1 and resistor R2 and resistor R3. Now do not forget that the voltage across parallel combination is the same. The voltage across parallel combination is the same. It is only current that breaks up. It is only current that breaks up. Don't forget this. So I have this, my voltage is the same for all of them, my V total is unchanged, it's the same for all. V total, the same, both V total is for this, is for this, is for this, has the same voltage. Has the same voltage, so voltage is not different. So there is no point writing V total, just write V, because it's the same voltage throughout. But if my current, total current is I, this is I1, this is I2, and this is I3. So that means at this junction my I broke into three: I1, I2, and I3. So remember, my I again equals to I1 plus I2 plus I3. Also remember that from your Ohm's law, my current equals to V divided by R. Therefore, that equation becomes V divided by R equals to V1 divided by R1. V1 is the same thing as V. There is no point because they all have the same V. Equals to V divided by R1 plus V divided by R2, because it's the same voltage they have, plus V divided by R3. Voltage is constant. Whatever is constant, you make it the subject. Look at the formula. Look at the first one. Current is constant for them. I made current the subject of the formula. Whatever is divided, whatever is divided, whatever is splitting, you make it the subject of the formula. For the first one, voltage split up, so I make voltage the subject of my Ohm's law formula. So voltage total is equal to this. So voltage is splitting up, voltage split up, so I made it the subject of the formula. Here, current is splitting up, I made subject of the formula here, current. So this is R total. So voltage is common, I cut it out. Voltage is common, I cancel it out mathematically. This one here goes one time, here one time, one time, one time. So voltage here 1, voltage here, that is, if I multiply both sides by 1 over voltage, it will cut out here. So my final answer now will be 1 over R total equals to 1 over R1 plus 1 over R2 plus 1 over R3. You do not need at your level to know how to prove these stuff. If you know them, fantastic, good. But if you don't know them, just know how to use them. So if resistors are connected in parallel, you are going to use this to get the equivalent or total resistance. If resistors are connected in parallel, you are going to use this to get equivalent or total resistance. If resistors are connected in series, you are just going to add up all the resistance to get the total or equivalent resistance. This is how to get your equivalent resistance. Now, Let me go back to the parallel combination. Let me go back to the parallel combination before I show my examples. There is one short formula I want to teach you. This short formula I want to teach you. If you have two resistors in parallel, two resistors, just two of them, not three. If there are no more than two, there is a short formula you can use if there are no more than two. If there are no more than two, there is a short formula you can use. Let's assume I have two of them like this, R1 and R2. So my total, according to the general rule, my resistance total or equivalent resistance would be 1 over R1 plus 1 over R2. Mathematically, I find my LCM. My LCM will be R1, R2. R1 multiplied by R2. That's my LCM. R1, R2. R1 goes here, R2 times. Multiplied by 1 up here is R2. Plus. R2 goes here, R1 time. Multiplied by 1, R1. So I say 1 over R total equals to this. Then I say so 1 over R total equals to that. But I'm looking for R total. I'm not looking for 1 over R total. I am looking for R total, not 1 over R total. I'm looking for R total. So if I flip this reciprocal, I have to flip the answer here also. It's like I'm saying Y over 4 over 1 over Y, or 1 over Y equals to 1 over 2. That means Y over 1 equals to 2 over 1. Same thing. So it's just reciprocal thing. If I flip it this way, I must flip that. So 1 divided by R total, that means R total divided by 1 will be equals to R1, R2 divided by R1 plus R2. You can see that. That means R total divided by 1 is R total. Will give me R1 plus multiplied by R2 divided by R1 plus R2. No one will ask you to prove this. You just need to know that if the resistor you have, if there are only two resistors, just say total resistor equals to product of the two divided by sum of the two. Product of the two divided by sum of the two. So nobody will ask you to prove all this, but just know that if you have only two resistors, you are going to multiply them together, then divide them by each, or divide this answer by the sum of the two of them, adding them together. So that's your R total. You don't need to do 1 over R, but if it's more than 1, 2, 3, 4, you have to use the general equation. You have to use the general equation if there are more than 2. Not more than 2, you can use your short form, product divided by sum. Product divided by sum. You can see that. So we're going to look at some examples now before we end the class. We are calculating the equivalent or the total resistance in this circuit. In the circuits, we have more than one. in the circuits. The first one, okay, I have 1, 2, 3 resistors. All of them are in the same loop. They are in series. So my R total for resistance in series is R1 plus R2. There are 3 of them plus R3. So my R total will be equals to 3 ohms plus 5 ohms plus 7 ohms, and I then have 15 ohms as my equivalent resistance, or R total, or total resistance. So it is 15 ohms. 15 ohms. This is an easy one. Let's go to the look for the equivalent resistance of the. You have 2 of these in parallel, and the combination is in series with this. 2 of these in parallel, and the combination is in series with this. So what you do when you see this type of thing, first convert this one to 1. First look for the equivalent of this parallel one. The most complicated one, you look for the combination, the equivalent resistance or total resistance. This and this will give me R total for that to be equals to product, because there are 2 divided by sum. I then have 6 multiplied by 3 divided by 6 plus 3. I have 9 or 18 divided by 9. This gives me 2 ohms. This gives me 2 ohms. That means everything I have here, I can represent it with what? 2 ohms. I can represent it with only 2 ohm resistor. I can represent it with only 2 ohm resistor, 2 ohm resistor. Garbage all of them, garbage them. I only need 2 ohms resistor. I put my resistor here, and that resistor is 2 ohms. So, because I'm done with these 6 and 3, I've reduced it to 2 ohms. I reduced it to 2 ohms. Resistor is now 2 ohms. So I reduced it to 2 ohms. It becomes simple. Then that 2 ohm is a combination of that complicated thing here. Then I do what? I add it to this. So my total resistance, total, this is total for this. But total, final overall total, R total, final overall total, not this small total here. I'm through with that. Let me clean it so it does not confuse you. Now my overall total will be equals to R1 here. This is now R1, and this is R2. This is equals to 2 plus 10, and my total answer will be 12 ohms. You can see how easy it is. The complicated one, do it first. This parallel one, do it first. Represent with it only one. You don't have to draw it. Just know it in your brain, or just put it with your pencil there. Just circle it and put it with your pencil. Then it's in series with this. This is another complicated one. This is a more complicated one. I want to find the equivalent resistance. This is in series with this. This are 2 is in series with this, is in series with this combination, and this combination in series with this combination, and in series with this. This, all these, and all these, then these, they are in series. So that's why our current goes this way. It gets to this place, it divides into 2, it reforms again, and continues again. It gets here, it divides into 3. But for now, we are not interested in the current. It recombines again and goes again to go in here. That means the total current leaving the battery or the cell enters 10 ohm. If you can know the 10 ohm, the current through this 10 ohm resistor is the total current. Then here it divides into 2. Since they are 4, that means equal. 2 equal. Then the current again comes here and divides into 3. They are not equal. Then recombines, and the total current again enters this. So here and here gets the total current. The whole of this gets the total current. The whole of this gets the total current. But before that, we talk about current. We are talking about the equivalent resistance now. Let's do the most complicated ones first. Let's bring this one to 1 resistor first. So we say 1 over R total equals to 1 over 2 plus 1 over 3 plus 1 over 2. My LCM 6, 2 in 6. I have 3 multiplied by 1, 3 plus 3 in 6, 2 multiplied by 1, 2 plus 2 in 6, 3 multiplied by 1, 3. My 1 over R equals to that. My 1 over R then equals to, this is 8 divided by 6. 8 divided by 6. So I'm not looking for 1 over R, I'm looking for R over 1. My R over 1 will be equals to, I turn it on, 6 divided by 8. And 6 divided by 8 is what from my calculator? 6 divided by 8. 6 divided by 8 equals to 0.75. You can see all these boils down to 0.75. So my R total for this is 0.75. Again, 1 over 2 plus 1 over 3 plus 1 over 2 because they are in parallel. So I get the LCM is 6. 2 here, it goes 3 times 1, 3. 2 here, 3 here, 2 times multiplied by 1, 2. 2 here, 3 times multiplied by 1, 3. 2 plus 2 plus 3 plus 2 plus 3 gives you 8. 8 divided by 6 is 1 over RT. Therefore, you flip, it's RT I'm looking for. R total will be equal to 6 over 8. You flip this, which gives me 0.75 from my calculator, which gives me 0.75. That means all this now gives me 0.75. Write it down. I solve that problem. I reduce it to a simpler form, 0.75. I get 0.75 there for it. So this guy is 0.75. If I like, I discard it just as I did before. Just as I did before to 0.75. I discard it. I have 0.75. 0.75. I leave this one there. I need it. 0.75. I don't need these guys again. Garbage them in there. So I have a new equivalent resistance now, which is 0.75. 0.75 ohms. Then this is another complicated one. Let's deal with this. It's easier because there are two. We use the short formula. R total equals to product divided by sum, which is equals to 4 multiplied by 4 divided by 4 plus 4. So R total equals to 16 divided by 8, which is equals to 2 ohms. 2 ohms. 2 ohms. So I don't need all this complicated thing again. I don't need these guys again. I need only 2 ohms there. I need only 2 ohms there. I need only 2 ohms there. Only 2 ohms there. Ohms. Only 2 ohms I need there. Two ohms. Because I've calculated everything here to be 2 ohms. You can see how I brought the complex things down. I brought the complex guys down. Complex guys here, I brought it down. So you can now see that the circuit now looks easy. It now looks beautiful. It now looks fantastic. What do? Then I have everything in series now. So I have less work. My total resistance now, overall resistance at the end of the day for my circuit will be my 10 plus 2 plus 0.75 plus 5. 10 plus 2 plus 0.75 plus 5. So this give me 12, this give me 17. 17 plus 0.75, my R total equals to 17.75 ohms. You can see how easy it is. You don't need to do too much problem. Just resolve the complex ones, make them single resistors in series with the others, or in series in the circuit. So the problem is solved. Problem is solved. Yet another one. This is a more complex one. This is a more complex one. You see, I have introduced switches here. I have introduced switches here. I have switch 1, switch 2, switch 3, and switch 4. I have introduced switches here. What can I do with my switches now? I can say, find the equivalent resistance when all the switches are closed. We just did that. When all the switches are closed, this is closed, this is closed, this is closed, this is closed. You do exactly what I just finished. You can rewind to see it. It's the same circuit. I can now say, okay, find the equivalent resistance when all the switches are open. When all the switches are open, find the equivalent resistance. The current goes this way from positive terminal, goes into this place. It cannot pass here, so this guy is cancelled. We don't need this guy. It cannot pass here. This guy is finished. This guy, we don't need it. If this place is open, it crosses like this and comes like this and comes like this. That means it's a series here, and goes like this. This guy is open. It cannot pass here. This guy is open. It cannot pass here. So, and this guy is open. It cannot pass here. This guy is open. It cannot pass here. The current coming from here cannot go here. It cannot go here, and it cannot go here. So, since the current cannot go there, it cannot come back to our cell. Then we say that the current cannot flow through the circuit. So you cannot even talk about the resistance. Then, in that case, resistance will not be existing because the circuit is not even working. So if you say 0 or nil, no resistance, then you'll be correct. Nil. Don't say 0, because if you say 0, that means current can pass like a speed of light. So now, let's look at another condition. If S1 is closed and all the other resistors, all the other switches open, S1 is closed. I close S1, look at it. It was like this before. Now I close it. Now I close it. Open it, I close it. I open it, I close it. I open it, I close it. Now I close S1. If only S1 is closed, let's see what happens. Current flows from the battery or the cell this way. It cannot flow here. It comes here. It cannot go here. It can go here. It cannot pass here. So only this guy will be affected. These two will be gone. Those two will not be there. Those two will not be there. These two will not be there. These two will not be available. They will not be available. They will not be available. This is still series. The shape does not really matter. It's still series. It's a continuous thing. It continues. It continues. It continues. It's still series. It's still series. Current goes like that, still in series, goes into that, goes like this, and goes like this. So, and this guy is also off because it's not part of our circuit now. This guy is not part of our circuit this time. So we see our current goes like that. It goes this way, it comes this way. This is still series. Forget about the way it is drawn, curved or not curved, it doesn't matter. Our wire will not always be straight, so it's still series because it's the same loop. It comes this way, same loop, not double loop, not two loops, no more than one loop. So you can see that everything is in series because everything is in the same loop. You can see. So if that happens, it's only this one is open, S1 is open, this is what we see. We now see our R total will be equals to 10 plus 4 plus 2 plus 5. So all the areas that current can pass, 10 plus 4, 14 plus 6 plus 5, that is 16 plus 5, which is 21 ohms. 21 ohms. That is 21 ohms. That is 21 ohms. So back to our question. Sorry. Sorry, I'm wasting your time, but this is important for you to know. Okay, back to our switch. Okay, it was like this at the beginning. So what do I do now? So you have seen it. If only this switch is closed, you have seen it. If none of them is closed. So whatever you do, anyone that is closed, you just allow current to pass through that, and if current can pass through that resistor and go back to the cell, that means that resistor is included. If current can pass through that resistor and go back to the power supply or the cell, that means it is included. If this is closed, you have this. That means current will flow. Cannot flow here, cannot flow there because it's open here. It goes this way. If this is closed, that means this is closed, then current will pass here, These two, you find the equivalent resistance, and you ignore this, and it comes here. You find the equivalent of this, and you ignore this. If this is closed, Then you find the equivalent of this, find the equivalent of this, you ignore this and make them in series like that. You ignore only this. And if all are close, of course, it will be just like we did before. This is how to solve this type of question. This is how to solve this type of question. Please, if you have any question, feel free to contact me. Feel free to contact us and we shall answer your question back and reply with another video, as you all know. Good day and God bless.